Okay, good morning, people, and thank you for joining us. We'll just let a few more people drop into the attendees. I know some of you are busy joining us now. Hope you are all well and not too freezing cold wherever it is you are. Certainly a bit frosty here this morning, so I think we're through into the autumn, but glad that some of you have been able to take the time this morning to join us on this webinar discussing some new and developing innovations which are, happening in rail freight, and some, expertise and new developments that I know will be of interest to a number of you. It's been a little bit of time since we did a webinar at RFG. I think this is our first one for a few months. We're perhaps a little bit rusty in how to do it, in fact, since we've gone back to real life events for the most part. So just a few reminders, obviously, from me about today and how it's going to work. We've got 3 presenters on today. They'll run through their slots. At the end of that, we will take some questions and discussion. If you want to ask a question, you can drop it into the question and answer box or the chat, and we'll pick them up. Please do ask your questions. It works better if you do. We are recording this webinar. It will be up on our YouTube channel a little bit later on, so you'll have the opportunity to look back on it if there's something in particular you want to see, and it'll be up on there. We won't be taking it down, so it'll be up on there for a little while, and then you can come back to it. And obviously, if you have to nip off or something and you want to catch back up on it later, we should have it up there certainly by the end of the week. If you are, interested in doing a webinar, being part of a webinar, or indeed being one of our events next year, we're in the process at the moment of getting our dates and calendar together for 2022. We've got some of those dates now on our website for our fixed events program. But if you are interested in presenting or speaking at something in future, then just give me or Yvonne a shout, and we'd be happy to help you with that. And if you're not already plumbed into some of our member forums, then obviously give us a shout around that as well, and we'll make sure you get that information. Okay, right, well, without further ado then, let us move on to this morning's agenda. And we're really pleased to open this morning with Ian Smith, who is the head of rail consulting at Tracsis, who are, I think, a well-known rail consultancy, certainly in the passenger railway, but doing an increasing amount of work to help the freight railway. So Ian's going to talk to us today about how we can improve operational modelling for the freight sector and the benefits that might bring. Ian, over to you.
Thank you very much, Maggie. Let me just press some buttons here. Hopefully we'll all have a share.
That's looking
good. Can give us a nod. Cool, thank you very much. Well, let's push some buttons and see what happens. Excellent, things are happening. Well, morning, everyone. Thanks to Maggie and Yvonne and all at Rail Freight Group for letting us have a chat this morning. I'd originally thought that this was going to be for an hour that you were expecting me to chat for. So you'll all be glad to know that that's not the case. I won't be talking here for an hour. But what I'm going to do is give a skim across a range of related topics that myself and my colleagues at Tracsis and some of our partners are very interested in. And if you have similar geekish interests, please don't hesitate to contact us or Fergus. Let's get into it. All right. So we're here to champion the need for more accurate modelling of freight in the UK. To do this, we're making a call for improved traction models. We need models that more accurately represent the capabilities of freight traction. For instance, acceleration profiles that correspond to real-world data. We have lots of anecdotal descriptions of our models not reflecting real-world train capabilities. But due to a lack of reliable evidence, these models are not being updated. And these are the models that we're all using to build both the timetable and assure its performance. Freight has a massive influence over service delivery and equally upon timetable simulations. And if we're not representing freight correctly, and it's typically that we're underselling the capability of freight, then we're making decisions about freight paths that are incorrect. This is only going to get worse as we push towards a timetable development process that is increasingly precise and based upon and verified by these very same models. So we end up with precision, but not accuracy. And of course, precision leads us into the false assumption that we have accuracy. In order to gain this accuracy, or at the very least, to build up a weight of evidence to challenge the existing models, we need access to on-train data and the corresponding loading data. We can then model those trains, and should any real train demonstrate greater acceleration than the model permits, then that element of the model is wrong. We need the loading data, as the timetable contains only a highly generalized description of the traction on what it's pulling, and this will invalidate the assessment if the simulation doesn't contain the same traction and load. Of course, this means we need a lot of data in order to find those occasions when the train is free to show off its capability beyond that available in the simulated version. This brings us on to the next significant influence upon simulation, modeling driver behavior. Unsurprisingly, the driver has significant impact on the speed profile of a model train. Again, access to the OTDR output, coupled with the description of the train's environment, that is, the signal states, then we can extract the impact of driver behavior from the capabilities of the train, which we've previously fixed. Tracsis has something called Centrix. It's a data feed from our remote condition monitoring network, reporting on, amongst other things, the state of each signal and the set of points, so which lamps are lit, which route's set, how much current is the point machine drawing, etc., etc. This data is currently being used in a study with Network Rail to examine the relationship between the availability of infrastructure and the movement of trains. Part of that output of this study being that we can determine how to better model how drivers react to specific signals. And by specific signals, in this case, I mean literally the location and color of each and every signal. We can see the profile of how drivers react to them. Given the more accurate models of the trains and the behaviors of drivers, we can restore confidence in precision and extract useful information from the simulation without concern that the model doesn't represent reality. We can make adjustments to the plan that we're modeling and see the predicted results of said adjustments. This will expose the ability to make decisions to provide tangible benefits for our operations. For instance, decisions that might provide us with the opportunity to save fuel or engine wear, signal a workload, or provide performance improvements. There's now a push coming from Network Rail to move from generalized planning rules to more precise running times and margins, and timetable planning based upon physics engines driving the very models we're talking about here. With to the second timings, we're moving into this high precision world, and only with more accurate models of freight available to the wider industry will we have any confidence in the output of these precise models used to build and test the timetable. Energy use within the model is clearly useful output. If we know how much energy we need to run a given schedule, we can modify that schedule, we can look at how that might save fuel and how to reduce carbon. Most likely reduction in energy corresponds to reduced acceleration. This will obviously impact upon the schedule, but with confidence that we're modeling the train system accurately, we should be willing to move that padding around the schedule and use it to save some energy. We can then use the planned reduction in acceleration as a performance buffer, allowing us to call upon that reserved acceleration to recover the train for the suffered delay. We must take account of the impact of longer journey times upon the customer and the crew, but as long as they're included in the model, we are free to play and find optimized paths. Something very powerful can be realized when we incorporate this within automated path searching, something we're developing in partnership with RSSB and colleagues in the freight and passenger operations, as well as Network Rail, and our academic partners from Southampton and Leeds universities. This approach can allow the wider timetable to be built around optimized energy use, while also incorporating a performance pad. It is then a matter of balancing the placement of this pad versus the interaction between potentially delayed services. Running perturbed models can demonstrate that this pad is in the most appropriate locations, but again, only if the models are accurate. Another aspect of modeling in energy use is its ability to take aerodynamics of your trains into account within the models. Currently, rail simulations make use of a generalized aerodynamic model, calling upon the Davis equations and a set of coefficients that have, for the most part, not changed in the last 60 years, and will provide the same value for two very different loaded freight trains. This was something that has been recognized and put into action, particularly within America and Australia, where they tend to have longer trains, so realize the impact of gap loading, more so than perhaps we have in the UK. But if we anticipate a growing need to push cargo from road to rail, then we should be expecting more mixed loads and be keen to advertise the carbon saving, plus access every little bit of profit that can be exposed within reduced energy costs. Our partners at Birmingham University have a test track sat just behind our offices in Derby, where Professor Soper launches aerodynamic models of trains through a wind tunnel. And you push the button and nothing happens. There we go. Here's a couple of pics of the physical models David's team use. Please note, these are not full size. They're 1/10 and 1/25 scale models. The best results for aerodynamic testing come from getting an actual train, running it up to a given speed on a flat section of track, and then measuring it to a coasting stop, again and again for different speeds and loads. Clearly, that's a lot easier to do on a scaled test track that you can see in these models and these photos than it is to do with live trains. So instead, you use a reduced number of real trains and use the wind tunnel experiments to populate a robust table of results. You can easily replicate with varying loads and distributions of these loads in a way that you couldn't do in the full-scale testing. This data is then used to validate computational simulations in dedicated aerodynamic simulation software. This helps us to understand the characteristics of the drag forces in greater detail and provides our rail simulator models with a more accurate coefficients reflecting the real loads that are being timetabled. We can then select the most appropriate traction models for each service being planned as we're developing or assuring those timetables. Note that the most appropriate may actually be the worst case model when we lack loading detail, but these can be refreshed with specific models as such information is available. With a widespread introduction of TMS, these models will continue to be influencing the operational plan right up until the arrival of the train at its destination. So we need better models. We need access to on-train data and the loading data that goes with that on-train data so that we can enable these better models to be built. Both the capabilities of the traction, given the loading, and the driver's behavior. Accurate and detailed information from the signal interlocking will support this analysis. We can then use these models to improve the planning of both passenger and freight to benefit both, and ensure that short-term planning, including on the day, has more scope to fix problems. If we have more white space being stripped out, having stripped out the unused paths, then again, we've got more opportunity on the day and can more accurately model these trains that are running given detailed loading data. Hopefully that wasn't overrunning. I do have a tendency to talk too much. I think we're going to hold the questions for later, if I am correct.
We are, Ian. Thank you. So,
cool. No worries.
in fact, you underran there. So if there's anything,
did I? All right. I'm running a little faster.
You've got a couple of minutes, but no, cool. We will hold the questions to the end because I'm almost certain that we're going to find some common themes and overlap with our other speakers as well. But thank you, really interesting. And I think I've had a little bit of exposure to the work on aerodynamics previously, and some really interesting work there, which is one of, as expressed to me, it was one of those projects which asked more questions than it answered, but kind of showed the way to answering the question if you knew what the question you wanted answered was, if you like. So certainly, hopefully there'll be some questions about that coming in.
Cool.
But thank you very much. Those of you online, please do drop your questions in the chat or the Q&A, and we'll come on to those a little bit later on. But let us now move on. Our second speaker today, Craig Purcell of Fenix Systems. Craig is going to talk to us today about the future of depot control and how we can run our depots and terminals in a way which is better, safer, and hopefully more cost effective than the way we run them today. So Craig, very many thanks, and over to you.
Thank you, Maggie. So my name is Craig Purcell, CEO of Fenix Rail Systems. We design, build, test and commission depot control systems throughout the UK and the world, actually. I'm here to explain why Tie-FenLock could greatly benefit the freight terminal and ports and intermodal operations, and how Fenix can assist achieve the safety goals, KPIs, and better running of the intermodal. I'm just going to show you a video, and then once we do that, I'll answer any questions. Thanks very much. Hopefully you can see that now. Can you see that, everyone?
It's coming. We can see your slides. Yeah. So if you go into slideshow.
And go to.
Yeah, from the beginning. Yeah.
Oh, actually, I've got to do this as well, haven't I? Share sound. Okay, lovely.
Yeah, that's looking good.
Okay.
Fenix Rail Systems is proud to be working with clients to install the Tie-FenLock depot intermodal and train control system in operational facilities across the country. As sole provider of this system in the UK, our clients have seen firsthand the difference this has made to depots of all sizes. The reason this system is being looked at as a game changer in the industry is due to its ability to be modified and extended depending on the requirements of the train facility, so as you grow, your system grows with you. But let's have a look at the difference this makes in greater detail from a safety and cost point of view. This is an average depot with a hand point control system in place. Usually this would require circa £25,000 of maintenance plus a significant amount of staff which handle management of the depot, training, mastering, maintenance of hand point levers, shunting, monthly inspections and more. The Tie-FenLock system increases safety and optimises the efficiencies within the train facility. By digitalising the system, data is fed into a central area, reducing maintenance costs, training, reducing the need for vocal communication where errors can occur, and the need for operational staff, allowing them to be utilised elsewhere. So with less people managing the system and a centralised control process, you're immediately increasing safety and on average saving £521,000 every year. This means the average depot receives investment payback within 4 to 5 years. This animation explains how it works in much more detail.
In any depot, yard or maintenance facility, it's essential that trains depart on schedule. Traditionally, this was achieved using hand shunters and staff on track directing trains around the train facility. Fenix Rail Systems is the sole provider of the Tie-FenLock depot control system, which delivers a range of services and control solutions for UK depots. The Fenix Depot Control System assists the depot operator by minimizing the time to set a route and to organize the traffic in the depot safely and reliably. The trailable point machine is SIL 4 certified, with an internal mechanical locking system, complete with a facing point lock, meaning external locking systems are no longer required. The depot operator receives communications via a visual display unit, ensuring safe operations at all times by avoiding conflicting train movements. The Tie-FenLock system receives the vital track occupied or clear information from the axle counter track section SIL 4 control circuits. These are pure hardware-based with a hybrid FPGA relays-based dual-channel design. Points control circuits communicate via serial bus with the SIL 4 central control unit. Each control circuit has its own microcontroller card for communication and individual functions. Up to 256 points controllers can communicate with one CPU. The system comprises of a computer-based interlocking with split functionality. The first section implements the safety and fail-safe requirements, and a second section implements non-vital controls and indications, continuously checking the current traffic and operations in the depot, monitoring for potential conflicts or dangerous situations. 6 individual signal controllers can be housed in one 19-inch rack. Each signal controller card is the interface between the central control unit and the local shunt signal, normally a dormant LED type head for UK infrastructure. This means the system is able to control hundreds of signals that can be modified and upgraded at any time with minimal hardware and software changes. The axle counter electronic evaluators are located in cabinets, REBs or buildings far away from any type of electromagnetic interference, meaning the Tie-FenLock axle counting system is far more resilient to overvoltage issues in comparison with systems from other suppliers. The Tie-FenLock depot control streamlines the personnel required to manage a large complex train facility, requiring only a depot operator supervisor working from one central control panel. The system is available in 4 main architectures, therefore it can be tailored to match the operator's requirements. It's fully compatible and can be interfaced with other depot systems, including the Depot Personnel Protection System. With lifetime support, system maintenance is simplified and made extremely cost-effective. The system has established a proven track record for its outstanding reliability and low maintenance.
This system is widely used throughout Europe and the UK. There are hundreds of businesses already seeing the benefit. We're here to assist you achieve your safety goals, optimise your operations, achieve your KPIs, help you grow and save operational costs. We'd be happy to answer any questions you have about the system and how it'll make a difference to you. Thank you.
So that's just about it, Maggie. Thank you.
Oh, I'm on mute. Thanks, Craig. Did you have a final slide?
The final slide is just about the cost benefits, really.
Do you want to share that?
So no, it's okay for that one.
Okay. All right. Okay. Cool. Thank you. All right. Lovely. So some info there from Craig on his software and depot control system, which I think is really interesting. And I know, obviously we have a lot of depots and terminals out in the freight world. So I think, hopefully that is something which we might have some questions and discussions on, and certainly of interest to people. So thank you very much, Craig. Okay, let us just take our final presentation then before we do move to some questions and discussions. And our final speaker is Paul Warren, who's the sales director at KeyTech, who's going to be talking to us today about driver advisory systems and how they can help us in future. So Paul, thank you very much, and over to you.
Thank you, Maggie. And thanks for inviting us here today, Maggie, and Yvonne for assisting in getting us to this stage. And also thanks to everybody out there online at the moment, live, but also to those that are watching it on the replay too. As Maggie says, I'm just going to talk through recent innovation of integrating live data from the signalling system into driver advisory systems to make them a lot smarter. So that's what today's about. But first, if I just give a little bit about us, we do things differently. What we look to do is take existing information processes and supercharge them. We're a bit that way about data and information. That's what we do. The result is highly accurate information that's meaningful to the user in the context of the user and delivered wherever and whenever it's required. That's what we try and achieve. We've been in rail information systems for over 20 years. Predominantly, our focus has been on passenger rail to date. 18 months ago, we took a decision as a company to focus also on freight. Probably wasn't the best 18 months to focus on freight because you guys have been really busy keeping the wheels of the whole country running in the background. However, we're trying to work how our existing experience can work across to freight. And we think there's plenty there. Just to give a little bit of context to that, we're providing real-time information on passenger trains across the UK, and the market leaders in that. And some of there's definitely some read across between what we're doing and some of the engineering that we've done to make that happen. We are the leader on that side in the UK and onto freight. Generally, when we engage with customers, what we're looking to try and do is understand whether they want to increase customer experience, operational efficiency, safety and security, or brand. Today, with driver advisory systems, very much focused on that operational efficiency. How can we make your environment more efficient than it was before? We've done this in passenger rail. So we have the system working in the UK. It's actually with the Siemens Class 350 train. So just trying to bring some of that experience across. Before I jump into any of that detail, though, I think what's worth doing is just taking a step back. As I say, we've really only been looking at freight for a few short months, but from what we've learned, there's a lot going on, partly because of the pandemic and focus on freight generally. However, I think overall there's a real desire for change. There's a desire for change from the freight market. There's definitely a desire for change out there from what we see. And any time when change is happening, the systems that you have and run and adopt need to be adaptable and dynamic. And that kind of dovetails back to the story today about driver advisory systems and how we can make them more dynamic and adaptable and fit your world. So let me jump straight in, and just in case there's people out there that aren't sure what a driver advisory system is, I thought I'd just give you some definition. But in effect, what it does is it gives at a glance advisory to a driver throughout the journey to meet the timetable in the most efficient way. And make that point carefully, meet the timetable in the most sustainable and efficient way. What we do recognise for freight is there might be some tuning required specifically to the parameters that you want to try and to achieve. And software is tunable. We often say we're only limited by the data we can get and our imaginations. So although there's great read across, there might be some tuning, and we'd love to collaborate to be able to determine how we can make that better. The premise of doing any driver advisory system, though, was to deliver benefits. And the key benefits listed below on that slide. As I say, if the system is focused on to timetable sustainably, the rest drop out from there. However, there's a problem. You will all know that the UK and any rail system is subject to change. It never always runs to type and to plan. So there are outside factors that will come along and affect the operation on a daily basis. The limitation of many driver advisor systems that aren't connected means that actually that type of change can, effectively null the advice and maybe even not be able to take account of the change at all if the journey, for example, was rerouted and that journey wasn't planned into the system, for example. So with those limitations, there's some implications. And if the system's not able to adapt and work in real time to real world environments, then potentially incorrect advice can be given. And ultimately, trust and adherence to the system will be compromised, and ultimately that will affect the derived benefits. However, there is a better way, and that's to connect the driver advisory systems and make them what we call situationally aware. These systems have onboard algorithms that are planned for specific routes and journeys. If we can add extra detail into the decision-making process, then we can get better, smarter results from it. Now, ordinarily, this connection is traditionally reliant upon ERTMS and ETCS. However, you will all know that those frameworks that Network Rail are delivering are very limited currently, very much normally focused on very short corridors. And we think that affects freight more than the passenger will, because of some of the routing that freight takes across the UK. So whilst ERTMS is on its way, and a traffic management system will certainly deliver great benefits, actually in the meantime there's a whole host of stuff that we can do, and that's where we stepped in. We looked at what is it that we can do to take a large proportion of what ERTMS would deliver into a driver advisory system, but make it available today and make it available where ERTMS isn't available, to make it ubiquitous across the UK. And that's what we did. So in effect, we created two innovations. The first innovation being the driver advisory system that is available in the cab for the driver to see. So the information that is being delivered and the look and feel of that information, so that the driver can understand at a glance what the best course of action to do. However, the biggest the biggest part of the innovation was creating this intelligent wayside engine that replicates some of what we get from ERTMS to really put a better definition and handle some of those problems that occurs, in terms of disruption, rerouting, speed limit changes in a dynamic fashion. One of the key points about the connecting to the signaling system, which is what we've done, is we know exactly where that train is. That is really important, because knowing exactly where that train is and what berth that train is means that we know that the target line speed, including any emergency or temporary speed restrictions, are taken into consideration in the algorithm so that the right advice is presented to the driver. And just so you know, GPS alone doesn't cut it. The problem with GPS is you don't get the definition down to the level that you need for example, parallel tracks and line speeds. Additionally, advantage of connecting into the signaling system is the paths are normally planned or are planned, and any changes to those paths can be determined as we go. So we're looking not just at the pathway, but the potential pathways that train can take, and therefore we can give tuning to the algorithm much earlier to again, avoid things like accelerating to a red light or avoiding to a route change, which the driver just couldn't see on their own. And then with the experience that we've got on the passenger side, what we do is we'll overlay, where need be, other data sources to help for other outcomes. And then again, that will come down to collaboration. And as I said before, we're keen to do that. So what's the outcome of all of this? Well, it's a system that is consistently, and constantly adapting to the real world and changing the profile of driver advice based upon that real world environment to get as accurate as possible in terms of the advice and guidance that's given to the driver. And the benefits are, that quality advice helps with regards to adherence and user adoption. And the outcome of that is we're looking to try and promote the least fuel usage as possible. How do we make this as efficient as possible? We already know rail freight is more efficient from a carbonisation point of view than road. How can we make that even better? And there are some other side benefits as mentioned on there. But that's not all. Because of the logging of lots of data, we've got a whole host of information, and it's interesting that some of what we're capturing might feed into some of what Ian presented earlier on today. But we've got a whole host of data that we're logging, but that data is useless unless we do something with it. So a user interface, a remote control user interface to look at the control of the system, the monitoring of the system, and reporting is really important. And what does that mean? Well, that means that you can use some of that more historic type data for better planning for the future, and maybe even putting into other systems. As I say, maybe Tracsis could use some of that output data. And also looking from a reporting point of view, is there any kind of coaching that can be given to drivers to better enhance the outcome overall? So in summary, I've just whistle-stop-tour through the difference between standard driver advisory systems and a connected and signaling connected driver advisory system for you today. Principally the three key things that I'd like you to take away from today is the potential cost savings that can be derived, how we can automate certain tasks to either make them more efficient from a cost point of view or remove the potential for human error, and then how can you use some of the data that the system derives and stores to help for future planning, to make better informed decisions in the future. And what we feel is combining this real-time driver advice and this historic data element creates a unique and very powerful tool to enhance the future operational efficiencies. And those efficiencies could either be used for cost reductions in terms of giving flexibility of increased margins potentially, or competitive advantage by reducing the end user price point to stimulate more demand into rail freight. And finally, couldn't get away without making this point, assist you in your journey to decarbonisation, because anything that we can do to make that journey using less fuel, less energy, can only be a better thing for the environment as well. And any questions, but I think we're handing over to the panel generally for any questions. Thank you.
Paul, thank you very much. Really interesting stuff. Do you want to just drop your slides for me and then we can see people
yes, of course.
In slightly bigger, I was going to say full size, but it's not full size at all, is it? So three interesting presentations there on, you know, as always, overlapping themes, and do that. So I'm going to go straight to a couple of questions we've got in. Peter Frost has asked, and Craig, this one is definitely for you. If the automated system ever fails, is a manual override system needed?
Yes, there is a manual override if required, and each sets the points can be hand operated, but there's a backup on all the systems. So if we lose power, then there'll be a period of time where, you know, we've got power supplied by battery operated.
Cool. And Craig, whilst you've got the mic, so to speak, obviously, you know, Peter, who's just asked that question, is developing a sort of a modern strategic rail freight interchange, which is, you know, a relatively clean environment. It's warehousing and intermodal, but you know, quite a lot of freight depots handle, you know, aggregates, cement, dust.
Yes,
steel,
that's right. So the system,
how robust is it to dirt?
The system is actually built for depots, and it was actually developed for terminals for you know, steelworks and such like. So it is really robust. I can show some videos of the tests that were undertaken to get the accreditation that we've got for it. It's far more robust than any other point machine, for instance, that I've seen previously. And it's also environmentally friendly. We don't use any hydraulics. It's all mechanical. Okay. You know, some of the testing that was undertaken, for instance, we had it in a coal yard in Germany for 7 years with no maintenance. It is maintained once a year. There wasn't any maintenance on this particular one for the test, and the manufacturer had to ask for the point machine back because it hadn't failed all the way through. So I've got pictures and evidence of all that, and also it's completely waterproof. The point machine, it works underwater, so it's completely sealed from the outside world.
Okay. And just in terms of its interrelationship, I assume it's totally separate to any mainline signalling, because
yes, completely separate. So. Yeah. So what we do is we've designed an interface for the UK that will interface with any type of mainline interlocking, from SSI all the way through to mechanical locking. All those are compatible now. So we basically can interface with any mainline system. We're actually being asked by, you know, freight terminals. So DERF 3 is one of the people we're looking at now to solve their problems. Mm-hmm. It's because it's built for depot control and intermodal control. Putting a mainline interlocking into a system like that wouldn't really work. It's not flexible enough. So we made sure that all the operability is there with our system, and of course it's far cheaper and more robust than it would be from mainline system.
Brilliant, thank you very much. Really interesting. I'm glad to see that you're, you know, getting some good conversations going there as well. Yeah. Right, I've got a question in the questions here for you, Ian, from Ralph Goldney. It says, very interesting presentation, many thanks. How much aero drag is from the loco end, brackets hard to do anything about, and how much from between the wagons?
Yeah, it's a bit of a piece of string question, that one. Obviously, without knowing what the formation is, generally speaking, it's somewhere like 60 to 80% of the drag will be from the local. But that still means you've got, you know, 20 to 40% from the wagons behind. and the models don't represent that very well, to be fair, which is what why we're on this drive to get more data. But what they have shown, where these studies have been done previously, particularly on the much longer loads, is the impact of that sawtooth effect. And it's less about the length and it's more about how it's arranged behind the loco at the front. And those sawtooth effects have quite a detrimental effect on your aero coefficients. And they're seeing quite a bit of fuel saving by just rearranging the wagons on the back. Now, obviously, that's easier said than done. But if they're not included in the model, then we're just effectively ignoring the problem. Once they're in the model, then you can start to make decisions. That's what decisions are all about. It's about being informed, and then you can make that decision. And right now, we're not very well informed.
Yeah. And do you think, on that basis, it's realistic from an aerodynamic point of view to think that we'll ever get freight train speeds up?
Freight trains to do what, sorry?
Go faster.
Yes, I mean, yeah, we can make trains go faster. I don't think that's necessarily the objective of what we need to do, though. I mean, for some of us, I mean,
it's always comes up as an aerodynamic issue. Yeah.
No, I agree. I mean, it depends on what we're trying to do. At the end of the day, we're trying to move efficiently. Large loads doesn't necessarily have to be quickly. Just efficiently is all we really need. Obviously, it depends on what your customer wants. If you're there for just in time, as everything nowadays is, then maybe you do have more time constraints on you, and in which case, you are switching to looking at some of the more passenger orientated traction and carrying your parcels around, etc. But yeah, it's not necessarily about speed. It's about the fuel use and representing the reality of the system. Yeah. Within the model, because back to what Paul was saying about CDAS, etc., and CDAS as a principle is excellent, but it only works when you've got precise information and the model's correct. To be fair, I've got a few questions for Paul if you haven't got some more questions later on. But yeah, if we can get the models right, then we can start making decisions, and those decisions may well be actually there's not much we can do about it, but at least we're saying that from an informed position, not hoping.
And Ralph's just added he's interested in closing up the gaps between hoppers and boxes. Is that the kind of area that can be beneficial? Yeah.
No, that's exactly it. That's exactly it. It's that sawtooth pattern which is detrimental to your airflow, and being able to solve that will save you. Will save energy.
All right. So look, I mean, Ian and Paul, a question there for me, because you both talked about data as being absolutely key to the future, whether that's through improved CDAS, which I think we can clearly understand the potential of, right through to the sort of more sophisticated timetabling models that Ian was alluding to. And I observe I might take chair's prerogative here, because Chris Jones is watching, and from Fraser Nash and Tim Jones from 3 Squared. So I might bring them in a minute. So I'm giving you fair warning, gentlemen, because I think, there's a lot of, really excellent development in this space, looking at, the very short-term pathing mechanisms, and also, the sort of predictive pathfinding and the examples that we've seen of that. But they're all chasing the same goal of data. And I suppose my question would be, to what extent is that data available from the locos that we have? It's just not being taken. And to what extent does it rely on Network Rail providing data that we haven't got? And how do we go about grabbing it? So I just really welcome your thoughts on that.
Yeah, I mean, Network Rail has for a while now been aware of the fact that data is key, and that they play a large part in getting us all reliable access to that data, and they're on that journey. I think that's probably as far as we can say on that one. I think there's a lot of data that's being held by the people on this call, I imagine, in the background. There's a lot of data being held, some of it for commercial reasons, but at the end of the day, we all need access to the data. This isn't Tracsis saying, please give us your data so we can do something clever with it. This is Tracsis saying, give us your data so we can do something clever with it, so we can all benefit from that. If Paul has a very good model of a particular train in his CDAS, we need to share that, because what's going to happen is I'm going to build a timetable that is using a less good model, and I'm going to be making Paul's train fitted with CDAS follow some schedule that is just inefficient, and then all the best CDAS in the world isn't going to help you out with that problem. So I think that's my takeaway for this is let's all share our data. You know, we can smudge around the edges where there's commercial sensitivities, but at the end of the day, what we're trying to build is the models so that the likes of Paul and myself, and even Craig on his depot side as well is going to need some understanding of how these tractions are moving around, and then of course for the freight operators themselves to save money.
And Paul, from your perspective, you know, where do you think the data gap's going to get fixed, or where's the real need?
Yeah, well, that's kind of a little bit of what we do as a day job. I think, as I say, and I've got to use the experience that we've got with passenger rail, because we haven't done this yet in freight. So, you know, that's why I'm here. We think there's a gap that can be filled. But what we tend to try and do is focus on what the outcome is, and then look back to find what we can achieve from a data perspective. What can we interface to? What can we integrate to? What can we obtain to overlay in different data fields? And then what's the quality of the data? And sometimes in the passenger world, what we're actually doing is we're colliding data together. It's kind of like a if this then that. So if this doesn't look right, does that look right, to determine, or is the data engine working correctly or not? And Ian, you're quite right. You know, in terms of without the right inputs, we won't give the right outputs. So the other part to that is, so what we've actually done is we've created you know, an algorithm, and what we need for that algorithm to work correctly is and I'm not the most technical person in the company, but what we actually need is the certain inputs. So, for example, power output for the unit, braking speeds, etc., etc. We know in freight we need to consider unloaded units versus loaded units, for example. That will change advice. What does the operator want to achieve? In the passenger world, the first and foremost, it's achieving the timetable. Secondly, it's doing it in a more efficient way. Actually, a freight operator might want to do things in a different way, be more efficient to begin with, and not be so worried about just in time. Or maybe there's certain elements of the journey that might need different profiles based upon the geography that it's going through. So that, yeah, Maggie, from what we've found, and certainly in the passenger world, I mean, Networks Rail's comment to us when we took this to them as a stopgap between ETRMS sections, was that you've come across a very novel way of replicating what we're building in the digital rail. And it's our background in some of the information systems from a passenger side that means that we understand that data. We also understand where to get it from and how to tap into it. So we haven't found that a problem so far, but open to new challenges.
And Tim, I'm going to pick on you because I think I've pressed the buttons to upgrade you to a speaker. If you are there, let me see if you're there. I'll ask you to unmute. If you're there, you might unmute. Maybe you've joined and then gone off to make coffee or something. No, he's unmuted. So Tim, I mean, you know, you're working this space. What's your view?
So Maggie, it's not Tim. I'm masquerading as Tim. It's Jason Dirk.
Oh, hi, Jason. Come on, you can answer the question anyway. Come on. I mean, you're in the data field here, aren't you, at 3 Squared? So,
yeah. So I think Ian and Paul are both on the right track. Excuse the pun. I mean, I think in terms of getting a full picture, we need to be taking data and streaming data from the train, from the data recorders on the train in real time if we can, and match that with on track and movement data, and amalgamate that together and then stream it back with all the data fields that Paul's been talking about in terms of disruption and train movement, so that we can get an overall picture of where the train is. And if we can do that, and as an industry, I know there are a lot of companies trying it. If we can do that and then squirt it back into the driver to give a proper real-time view of where the train is on the network, and what is potentially impeding the progress of that train, then I think we've got a better stab of achieving that. And as you rightly say, I mean, 3 Squared are moving forward in this space as well. We've got our path planner solution, and we've also got driver advisory solutions as well. And we're looking to join the two together to improve what we offer to the freight community.
So it sounds like there's some common ground here on data sharing, as Ian said, and it sounds like people are working on it. One of the things that still worries me, and I'll be open about it because I don't think there's anyone from Network Rail on the call, is that you guys are doing a brilliant job at the sort of above rail stuff and getting that interface there. It worries me that we're still driving around with train cabs with bits of paper in, telling us where speed restrictions are, and unless there's going to be a system introduced where the infrastructure can tell you it's got a speed restriction, we're going to be losing it. So is there a collective, are we satisfied with the progress that Network Rail are making and planning, or do we need to push them harder?
Yeah, I'll step on. I was going to say, well, they're not on the call, but they'll be on the YouTube. Yes. Yeah. The more can be done. How's that? Yeah, we're supporting them, looking at possession planning, and part of that, we're dropping ESRs and TSRs and such into that functionality. But that doesn't sit within their core planning system, and it isn't distributed. Their APP work is pushing ahead finally now. That's the replacement for PSS basically. So hopefully, I'm sorry, PPS even. So hopefully we'll be in a situation where that data will at least be held electronically and consumable. Whether or not it's going to be handed out or not is another matter. I'm aware that they are trying to get all these data flows into one big warehouse and then start handing it back out again, perhaps with a bill attached to it. But I mean, to be fair, I'd be willing to pay for it if it's correct. At the moment, the issue is that you've got to read a few post-it notes and try to cast the bones to find out exactly what's going on the network. So yes, they're on the right path. It would be nice if they could be a little bit quicker about it. Okay, cool.
So I think, Maggie, from our point of view, we've certainly had access to that data. What we try and do is trial and test data, and if we're not happy with it, we won't use it. We do the same on passenger. Even if we've got an interface to another third-party organisation that will sometimes, for example, passing us capacity data. How full's this carriage, and then we're going to put it into passenger information, for example, or to CIS on stations. If it's not valid, we won't use it. We'll drop it and then bring it back in. But the other part to this is create a manual override. So in that back-end system is have the ability for the operator to actually create their own profiles in terms of maximum speeds for certain routes. And that's another way of going about that. So you could take that paper out of the cab because actually someone's in control of it in mission control, for example.
So you can get around the fact that even if it doesn't come from the Network Rail system, you could, as an operator, avoid the need for each of your drivers to take it. Yeah.
Yes, absolutely.
Yeah, that's helpful. Yeah.
And just an aside on that Maggie, sits in role selling our wares as well. Centrix RCM is a system that Tracsis provides to Network Rail that gives you a far better view of what's actually happening on the infrastructure. Paul, are you pulling your signalling information directly from the interlocking, or are you pulling it from the TD net or something?
TD feeds, yeah.
Yeah, so we find that we've got something like a 5 times resolution of data as what you're getting from the TD. So the TD basically only gives you signal birth steps, whereas the actual track circuits, obviously, there's more track circuits than there are signal births as they're described in TD. We found on average you get about 5 times more detail, particularly around complex areas. So obviously, if you've got a bunch of trains rumbling around a station, etc., we can see far more precisely where they are exactly on the track. Now, that information is one of the many data feeds that hopefully Network Rail will be providing to the industry at some point in the future. But for now, at least, we can give you a peek into that, Paul, if that can help you.
Okay, cool. Okay, lovely. Well, I think the only other question I've got online now is, can we share people's contact details after the event, and I'm assuming that will be a yes. So
Sure, no problem.
so if any of you on there would like to to have contact details, we can get them over to you afterwards. A note in the chat there from Ralph Goldney, who's joined the webinar today. Ralph is leading some work for our Rail Safety and Standards Board on digital couplers, and we have a roundtable on that we're providing the platform for Ralph tomorrow morning. If any of you are interested in that workshop tomorrow, please give us a shout, or we can patch you into Ralph, who's doing some work on whether or not or what are the costs and benefits for digital couplers in a UK context. So that's another thing that is going on in that space. But I think it's been really interesting today, to particularly understanding where we've got developments which are, as always, additive to each other. I think we always find that when we pop speakers together, there are common themes, common overlaps, and areas where hopefully interest in working together. So thank you to Ian, to Paul, and to Craig for their input today through really interesting, different but overlapping topics, and I think some obvious areas where we can see that the benefits are just beyond the tips of our fingertips, really, and there to be grabbed for. So a huge thank you to you all, gentlemen, for speaking today. Jason, for stepping in valiantly when I bullied you up from an attendee to a speaker, and to those of you today for your questions and your thoughts as well. So we will conclude the webinar now. I'll give you 4 minutes of your day back. Thank you very much, and hope to see you again at another event soon. Thank you all.
Thank you, everyone.
Thank you.
Thank
See you
you.
next time.
Take care. Thanks very much, everyone.